Fine. So your next chapter is lubrications. Are you fine? So we are going to talk about why do we need lubrication for our aircraft car systems. The reason for the need of lubrication is first one is to reduce your friction and wear. So if you reduce your friction, that means the primary cause for having friction is you're going to have some amount of dirt particles or any two parts are not moving in easier way. So to lessen this friction, because if you have more friction, that means our engine ka temperature is going to increase. Any two surfaces that rub against each other is going to increase the temperature, which is not good for our engines. So for that primary reason, we are gonna lubricate our engine. Next is we have parts. So if two parts are continuously rubbing against each other without lubricating, that means they have more amount of friction. They are gonna wear off way too soon than whatever the lifespan of that particular part should be. So in order to avoid those things, we have to lubricate it. So this is the primary reason why we lubricate our surface. Now, what is your lubricant gonna do is it is gonna separate your moving parts. That is, whatever parts you have, it is gonna form a thin layer between each other, which is gonna help us in creating lesser friction, which is gonna reduce the wear of our moving part. Now we use many different part of lubricants. That is, it can be oil, it can be grease that is going to be of high viscosity. These are used in heavy machineries and stuff. We can use powder as lubricants, like to reduce the friction between two surfaces, and then we can use solids also. So these are the four main types. In our aircraft, we primarily use oils. We don't use grease or powder or solids. Then we have two types of lubricating. That is, we have pressure lubricating or we have splash lubricating. So the difference between pressure lubricating and splash lubricating is pressure lubricating may we are going to use pumps, that is oil pumps and all those things, which is going to spray lubricating oil under pressure into any system that requires lubrication. Splash lubrication is whenever we use a wet sump system. In that case, the movement of your crankshaft and your piston is going to help us in getting that lubricating into your pistons, and all the primary places are going to be lubricated. So these are your difference between pressure lubrication and splash lubrication. So how are we gonna, what are the primary and secondary tasks of your lubricating is primarily it is to reduce the wear and tear. That's it. So it reduces the friction between the components, which is going to reduce the heat, which reduces the wear and tear of your components. But not only that, your lubricating has the other functions also. That is, except for like second one is we are going to use it for cooling. So we can use engine oil and all those things to cool our system down, which helps in taking away the heat from the engine. And you can use sufficient methods of cooling that oil down, which is going to help us in reducing the overall temperature of your engine. Next is it will clean your system. That is, whenever oil is sprayed, even if there is any dirt or debris that is stuck inside your piston ka cylinder walls and all those things, when oil is sprayed, it will come off with the oil so that it doesn't get settled inside your engine cylinders, which is going to create something called as an hotspot. So in your hotspot, if you have something get stuck, that will create a, if the temperature of that rises to a certain extent, when the fuel is being compressed, it is going to automatically ignite. Instead of spark plugs igniting your fuel, your hotspots will ignite your fuel. Then we can use your oil for excluding corrosion. That is, whenever, because it's all metal and we are taking it to very extreme temperatures. We are taking it to super high temperatures and super low temperatures also. These are prone to get corroded very easily. To avoid corrosion, we can use lubricating oils to avoid your corrosions. Then we can use hydraulic as a hydraulic medium to avoid shocks and all those things. We can use it as a dampening agent, which is gonna absorb some amount of shock, because your any oil or grease or whatever we are gonna use it, since it is not very of low viscosity, it has at least some amount of viscosity. It can take or it can reduce the amount of shock that is being encountered on your engine car component. So it helps us in reducing your shock. Then it can also indicate our engine car life, that is how our engine is working. Are we going to have an engine failure, or is your engine working normally? In case if your engine temperature goes higher, that means you have lesser oil inside your system or your engine is overworking. In that case, it is going to give us an indication that we are going to have an engine failure. So all this medium so all these things can be given to us by the use of your lubricating car system. And the most important thing is it is going to have an effect on our power. That is, the more friction that we have, the lesser the lubricating power we have in our engines, the more friction it is going to be. That means our frictional horsepower is going to be on a higher scale, which means our brake horsepower is going to decrease, because brake horsepower ka formula is indicated horsepower minus frictional horsepower. So at the end of the day, if you have more friction, we're going to lose a lot of energy. That means our engine is not working sufficiently to get our job done. So these are your primary functions of your lubricating system. Next is we are going to talk about your wet sump and dry sump system. So wet sump is basically your splash lubricating, and dry sump is basically pressure lubricating system. Now these are the only two systems that are available, and depending upon what is our exact requirement, we can either choose a wet sump system or we can choose a dry sump system. So the basic difference between your wet sump system and your dry sump system is where and how your oil is placed and how it is transferred to your engine. In first, we'll talk about your wet sump car system. So wet sump system, like our Cessnas and all, we used wet sump system where you're gonna store the engine oil right under the engine. So you're gonna have a engine sump which is gonna have all the engine oil, and by the movement of your crankcase, the crankcase is gonna throw the oil around it, and it is gonna help us in lubricating. But the problem with this type of lubricating method is that we tend to over lubricate our engines. That is, we tend to cool it down way higher than whatever is actually required. We lubricate it way higher than actually what is required. So that is gonna cause a little problem. Whenever we are maneuvering your aircraft, let's say we like bank to one side of one side. In that case, again, the whole oil is going to go towards one piston. So one piston might get over lubricated. The other piston might not get lubrication at all. So these are the problems with having a with some system. And the other thing is about your temperature. We cannot control the engine oil ka temperature since it is stored right under the engine and your engine is constantly running. Your engine oil temperatures tends to be on a very higher scale. So this causes your whole engine ka temperature to be always at a very high temperatures, and might get even higher if your engine is being overworked. Your oil, we don't have any filters or nothing as such inside your whole wet sump system. So there are possibilities that your oil will get contaminated. That is, you can have any sort of carbon deposits coming from the engine will be deposited into your oil sump, which will stay there forever until and unless it is sent in for maintenance and removed it. So these are the problems by using your wet sump system. And then the amount of oil that we can carry is also going to be constricted by the use of a wet sump, because we can only carry some amount of oil, rather than in a dry sump system we can carry a lot of oil because it has a separate oil tank. So that is about your wet sump system. Second one is your dry sump system. So in a dry sump system, as the name suggests, dry, the sump is going to be dry. We are going to store oil in a separate tank, which is going to be away from all your engine working components. That means our oil ka temperature will be cooler than whatever we had in our wet sump ka system. Now we are going to use a lot of pumps. We have two pumps in our system, which is basically your pressure pump, which is going to be here, which takes oil from the tank, and it is going to pressurize it and send it into the engines. You have the second one that is called a scavenging pump. That is going to take all the oil and it is going to send it into your radiators and then back to your engine ka oil tank. So these are your oil can. Then you have like filters and all those things, which is going to help us in removing any dirt or debris that is there in the lines. And with the help of the filters, you're going to have a magnetic line inside the filters. The job of this magnetic piece is to attract any amount of metal components that are circulating in your lubricating system. Why do we have to have this is because if you detect some amount of the metallic elements inside your engine oil, it means that your engine is wearing a lot. That is, the engine components are rubbing against each other and you have breakage of your engine components, which indicates that there is like more amount of lubrication has to be done, or sometimes your whole engine component has to be replaced. So this is an identification on how to find if your engine wear is on a higher scale or not. Now, the whole function of your engine oil and all those things is the same. It doesn't matter from engine to engine. Any engine, we are going to take oil from your oil tank. It goes to the oil filter, then it goes to the pressure gauge, scavenging pump, oil cooler, oil pressure gauge again, and we're going to have it back. That is, first one is you have it in your oil tank, and this is also called as an hot pot. You have suitable scale to measure how much amount of oil you have inside the tank and all those things. Then you'll have a oil temperature gauge inlet, which is going to measure the temperature before the right after your oil cut tank itself. Then it goes to suction filter where it is going to be filter out for any particles or debris, some dirts, whatever, which should not enter into our engines. Then you have your pressure pump. So this pressure pump is a helical gear which is going to spin against each other, which pressurizes your oil, and then it goes to a pressure filter. This pressure filter will be even more minute than your suction filter. So we in your pressure filter, whatever furthermore debris that you have is going to be taken away, so you don't have any debris at all. And at the end of your pressure pump, you're going to have a oil pressure gauge which is going to measure what is the amount of pressure that goes into your engine. And then it is going to be sprayed into the engine core components. And once the job of lubricating is done, the engine will start dripping off the oil. It will go to scavenging filter, because at this filter you're going to have carbon deposits. If your engine is having more amount of wear, there will be small metal pieces and all those things which can be collected, and then you can verify if everything is working properly or not. Then that thing goes to a scavenging pump. So again, your scavenging pump is also the same helical gear, but this is going to be slightly bigger than whatever pressure pump ka gear we have. So your scavenge pump ka gear is going to be slightly bigger because we have to overcome gravity in pushing hot oil up through the into the tanks again. So to overcome this gravity, in this case you had the assistance of gravity, but here you have to overcome the gravity. That's the reason your scavenging pumps is slightly bigger than your pressure pumps. And it is going to go through your radiators, which is going to use air inlet. So that is, you're going to use ram air to cool your oil down. Once the oil is like will be circulating up and down through these radiators, once the job of cooling is done, it is going to go through your oil lines and back into your oil tank again, and it is ready for the second round. Now you will also have additional areas where you can use your engine oil, like our feathering oil. So in case if our aircraft has to be feathered, we have to send in oil from our engine car instrument casing, which is going to go into your propellers, which is going to feather it. So this you will have an additional mechanism and stuff. Then we have something called as a hot pot. So what is a hot pot is, inside your whole tank, you're going to have small holes like these. Now, let's say our aircraft is standing, it is on a very cold day. Your oil tends to freeze. That is, it gets a little, the viscosity of your oil is going to increase. But there will be some amount of oil that is there inside your whole oil, which has not hit that much high amount of viscosity, which is still like liquidy. So when you start your engine, when the pressure pump starts running and all those things, this hot pot ka hole will not allow thick oil to flow through it. It will only allow thin oil, that is with low viscosity, to flow through it. It is going to flow through the pumps and into your engines, lubricating. Once your engine starts running, your oil starts heating up, it can then bypass this valve. So before our engine oil is already like very hot, until that point, we are not going to send our oil through our radiators because it is already cold. We don't want it to cool even more further. So we can allow it to go through your bypass valve. So this is a one-way bypass valve, which is gonna go through this way, overcoming your radiators, bypassing your radiators, and then it is gonna go into your tanks. Now, since it has touched the engine and come, the oil that went into the tanks, it's gonna be hotter. This hot oil can be used to melt some more amount of your oil inside the oil tank, which can then be used to cool your engines down once sufficient temperature has been attained. In that case, the whole bypass valve will close down and all your oil will go through the radiators and then go into your oil cut tank. So this is how your whole dry sump system is gonna work. So you have like oil pressure relief valve. If you send thick oil through it, the pressure is gonna be very high on these lines. To relieve that pressure, instead of sending it through the pump, it will be sent through the oil pressure relief valve and into your engines again. So this is all gonna work only whenever your oil is very cold and thick. If it's very thin and it is not as thick as that, in that case, very hot also, everything will work as normally, and it goes to the radiator and your air is gonna cool it. So this is the working of your dry Samka system. So we talked about your whole oil cut tank. That is, it is going to be made up of sheet metal, and you're going to have internal baffles. What internal baffles is, we are going to break down your whole oil cut tank into so many different sections. So breaking down into sections is gonna limit the amount of force exerted on the walls inside within the tank. If you had one single tank of this big, if your aircraft was maneuvering left and right, in that case, all the oil is gonna hit this side, or all the oil will hit this side, which is gonna cause us lot of problems because of the moment of the whole oil cushion. So when you baffle your tanks, it reduces the whole oil forces hitting against the walls of each end of your tank. Then these are also going to be strengthened because they have to overcome and all those things has to be done. Then your reservoirs are going to be placed wherever possible above the engine. Why above the engine is, in that case we can use the help of gravity and your pressure pump to help in feeding the engine with high pressure. So in it is going to be your pump shouldn't have to do all the work to do all the job of pressure like lubricating your engine. Second one is your oil return will start whenever you start your engines. So it is goes to the oil drains, and after shutdown, the scavenge pump will return, like it will be at the oil sump itself, because your engine will still be dripping down oil. Once you start your engine again, then only your engine oil is gonna go from there. Your scavenging pump is gonna do the job, and it is gonna push all the oil back into the tank. So if you are coming right after a flight, if you shut down your engine, the oil still that was lubricating your engines will be dripping down inside your scavenging tank, and it will be still on the line because you have to overcome the gravity that has to send it back up again. So this will be done whenever you start your engine again. Until that time, your scavenging tank will always have some amount of oil, and your oil is going to expand whenever you heat it. Anything that we heat is going to expand, so we have to account for that also. That is why your oil cut tank capacity, if it says 7 quarts, you have to fill they'll say that fill it only until 6 quarts. We leave 1 quarts because your oil is going to expand upon heating. Then we have another problem, that is frothing of from aeration. So what frothing from aeration is, whenever the oil is being aerated, that is you're going to have some amount of air leaking into it, and this is simply being sent through the pump and all those things. There is going to be some amount of froth forming over the engine ka oil. This is not good for us because frothing is going to reduce the amount of lubricating capacity. To overcome this lubricating capacity, we should use some kind of detergent wala stuff that is gonna remove all the frothing from the oil. And then you have to also allow oil to be displaced from your variable pitch propellers and your feathering mechanism, because both variable pitch propeller is using engine oil to control their pitch. So if you change from either high pitch to a low pitch or low pitch to the high pitch, either oil is going to go from the tanks to the propellers or to the from the propellers to the tank. So we have to account for that amount of oil also, and then we have to carry the oil. Now we talked about your hot pot, that is there's going to be small ports which is going to restrict your thick oil flow, ensuring that only warm oil circulates through the entire ones. Once the warm oil reaches the tank again, it is going to melt the other thick oil, and it helps us in getting all the oil back into the line again. And you also have a suction filter which is going to clean any dirt or debris that you have. You have a feathering reservoir that is going to help us in whenever your lower part, that is your lower part of your engine oil car tank, is going to have the feathering port, which ensures that you have always oil that is readily available for feathering your aircraft. Even if your, let's say your oil tank is leaking in some case, there will be some amount of oil that is always remaining left, which can help you feather your engines down. You won't go without feathering at all, because feathering is one of the most important things in our multi-engine car aircrafts. Then you have scavenging, return, and deaeration. That is, oil from the engine is going to pass over to the deaerator, where it is removing oil and sorry, it removes air and it removes the frothing possibilities. And then only it is sent into the hot pot. So you don't have any type of aeration that can occur because of this process. And then you're going to have crankcase is going to be vented. The first day when we talked about your components of your engine, we said about the crankcase, which is going to have small holes in it. That vented crankcase avoids your oil to be cold from there, and it also relieves some pressure inside the crankcase itself. So this helps us in removing your pressure inside the crankcase, and your oil can do the job of it. Mhm. So this is how your suction filter is gonna work. So your suction filter is made up of different components and all those things, where you have the filter element. So your suction filter is basically very, very like coarse wire mesh that is gonna be twined with each other in a rectangle form or a square box, which allows your oil to pass through it. So you are going to have a suction filter before the pump, where your oil is going to pass through this particular suction filter, then goes into the pump. Now this is going to remove any large solid particles that is there in your oil, like carbon deposits, any dirt, metal pieces, all those things will be removed, and then your oil enters into the pressure pump. Why do we do it? Is if some amount of large pressure, large particles that enter into your helical gear, there are chances that it can damage your helical gears, and your pump will lose the efficient way of supplying oil into your system. So to not let this happen, you're going to have a suction filter. And whenever you change your engine oil, like any maintenance, 100 hours or annual or whatever, they'll always replace this oil filter, so that you always have this. If your oil filter is blocked or it is clogged because you didn't change it for a very prolonged time, then your oil pressure gauge will indicate that you have very high oil cup pressure. That means it is not going into your system, so you have to use some other way of taking oil from your suction cup filter. So you have to replace your suction filter. Then this is about your pressure pump. So your pressure pump is basically going to be combined of two helical gears. So this is called as an helical gear, which is going to rotate in two different directions. Why? Because this is basic like engineering and stuff. When one gear rotates in anti-clockwise, the other gear will definitely rotate in clockwise direction only. If you have to have some other gear, if you want something to rotate in anti-clockwise, you have to attach a third gear, then only it will start rotating in anti-clockwise. For this case, we only want our oil to be sped up and be sent into it. Now, what your helical gear does is it takes oil from the inlet. Since the speed at which it spins, it is going to use centrifugal force to take it through the wall of your instrument ka casing, that is wall of your pump ka casing. This is going to increase the pressure, and once the pressure increases, it is going to go through your oil outlet. So this is how your helical gear works. Second is, if your pressure is high, to relieve your pressure, we are going to use a non-return valve. So, or this is also called as a pressure relief valve. In this case, your oil pressure can only go through this way and not through the opposite side. So your oil is going to come through this pressure relief. Sorry, your oil will go through this way. That is, it will go through up like this and not come down through like this. How it is going to work is, if your pressure increases, your ball is going to be pushed up because of the excess pressure. When your ball is pushed up, the oil will again go into your inlet again. So this whole cycle will be keep on continuing. That is, it is goes from the outlet. Since your pressure is high, it doesn't want it. It will go here and then it will come down. We also have like engine pressure pump cutoff switches and all those things. Once it senses that there is high pressure and your pressure relief valve is activated, the pressure pump cutoff switch will cut off your oil pressure supply. So after your pressure drops, where the ball will also drop because there is not excess pressure that is holding your ball up. When it drops down, your pressure pump switch will activate again, and you're going to have the oil flow coming into your engines again. So this is a constant thing that is going to keep on happening inside your engine pump. Now, your oil pressure is dependent upon what is the speed at which your pumps is spinning, what is the oil temperature, and what is the resistance from the lubricating component. So any of this increases, you're going to have an increase in pressure. If your pump speed increases, that means faster spinning, more centrifugal force, more pressure it is. If your oil temperature increases, that means more oil is going to flow through it. Again, your pressure is going to increase. If your resistance from the lubricating factor, that is, if two pads are like grinding against each other a lot, then also your resistance will increase. That means your pressure is going to increase. Now your pump capacity is, there should always be minimum oil even in worst case conditions. That is, you have low pump speed and high oil temperature. Then also there will always be a minimum amount of oil. Not all oil will leak out of the system and you won't have oil at all. So under normal conditions, in case if you have increase in flow of your oil from your tanks to all the cylinders and all those things, which means there is high pressure inside your cylinder. So one indication that you are going to have, if you pour by mistake higher value of oil, let's say your aircraft should hold 6 quarts and you hold like 7, you put by mistake 7 quarts, you're going to have excessive high pressure oil indication. In that case, you have to drain your oil out of the drain hole, which is going to relieve the pressure again. That is the one of the reason why you have a pressure relief valve. So your pressure relief valve is to limit your maximum oil pressure, and it opens at a preset value. That is, whatever value it is determined that it is going to be dangerous for our pumps and all the whole engine itself. In that case, the pressure of the oil will push the ball upwards, which is going to send oil back into the pump again. So your whole operating ranges is, it depends upon your whole range of your aircraft. That is, even at idle RPMs, your engine oil should not be getting very cold where it is gonna become thick again. At very high temperatures also, it should not melt like at a very higher rate where it is gonna melt and you're gonna have very low viscous, which means that there is no lubricating activity that is happening, which is gonna increase the friction of your whole value. So the oil should be operated at certain ranges, and it is like whole on the whole scale, it is from idle to your max RPM. Then you have your check valves. So check valves is it is basically a one-way return valve. So in a dry Samka system, the oil tank is always above the pressure pump because and to allow your gravity to be fed. Now, why this is above your like engine is because we use the help of gravity with the help of your pump to pressurize your system so that your pump only doesn't have to do all the value of sending all the engine oil into your engine to lubricate it. Now, there is a problem with this thing. That is when the engine is stopped and the oil is hot and thin. Gravity can be forced because since it is gravity, the gravity will start like letting your oil flow into it, flow through the pumps. And since these are gears and stuff, there is going to be holes here and there. It will flow through the inlet, flow through the filters and all those things, then go into the engine where your engine is going to be flooded with oil. To not let this happen, we are going to have a check valve. That is a non-return valve that is going to stop the oil flow whenever your engine is shut off. So this helps us in not letting the oil go into your engines and flood the engine. So next time when you start the engine, your whole engine will not be covered with oil. It will only have whatever oil is really necessary for your engine is stopped. So this may be a lightly spring overloaded valve like whatever we saw in the previous diagram, like this. This is one valve, one way return valve. If you put it in ulta, it is going to help us in stopping your engine oil. Second one is it can also be a electrically operated shut off valve. So depending upon how complex your aircraft is, you can either have it as a manual method where lightly a spring loaded valve can be used. If it's a very big aircraft and stuff, you can use a electrically operated shut off valve, and the valve will open automatically whenever your engine starts, because as soon as your engine starts, you need some amount of lubricating to be done in your engines. So these are your check valves. Then you have your pressure filter. So your pressure filter is going to be kept after the pressure pump. So in the diagram, if you remember, it is going to be kept on the down part. So this helps us in filtering out even minute solid particles, very very small, which pass through the pumps and all those things before entering into the engines. Because our engine has to be as much as clean as possible. We don't need any debris and stuff, which can become an hotspot as time passes by. So even if there is a small stone which scratches your engine compartment, that will create a hotspot. There will be some amount of carbon deposits that get stuck, and during each combustion, that carbon deposits gets bigger and bigger and also hotter and hotter, which can become a hotspot, and then you're going to have detonation that is happening. So this removes your smaller particles. And then you have your relief valve that we already talked about it. That is your bypass valve is going to be fitted in your pressure cup pump. So this is going to be open whenever your oil is cold. That is, it doesn't allow your oil to enter into the oil pressure pump, so that it is going to directly bypass it and it is going to go into the engines. And whenever your oil is hot, this is automatically going to get closed. And this also protects your engine even if you have any engine failure, any pressure pump ka failure and all those things, so that you are going to always have a constant flow of your oil into the engine with the help of gravity now. But that's it. Then we are going to talk about your scavenging pump. So your scavenging pump is basically it is going to take all the oil from the scavenging tank and bank into the oil car tank through your radiators. Now whenever there is an oil that is accumulated, the pump is going to be slightly bigger because it has to overcome gravity, and it is going to take all the oil back into the engine car tank. So that is the reason why you have a bigger size pump than whatever your pressure pump is. So whenever the engine stops, the oil drains into the sump and it is going to stay there until next time your engine starts. Now, when your engine starts, and this is the other reason why your scavenging pump is bigger, because whenever your engine starts, all the oil would have been dripped down. So technically speaking, your oil tank doesn't have all the oil capacity. So if you say, let's say our whole tanker capacity was 6 quarts, and when you take out your dipstick and see you only have 5 quarts, we should not refill the oil, because one quart or half a quart of oil will still be left at your engine car tanks, engine car scavenging pump or scavenging sump. So that is gonna add up to it. If you add 1 quart more, let's say 1 quart of oil was there at your scavenging sump, in that case, the total oil capacity of your whole system has now been 7 quarts, which is going to be indicated as a high pressure warning, because we have more oil than whatever is actually necessary. So we should always not refuel, not add oil until and unless it is really, really necessary. Now, your to keep your whole sump dry, the scavenging pump is going to be made up of 25 to 50% larger than the capacity of your pressure pump. So this is the reason how big your scavenging pump is made, because it has to drain all the oil as soon as your engine starts into the tank, so that you have more engine oil coming from the tank into the engine. There's no point in engine staying in the scavenging sump, because it is not going to lubricate it on its own. Next is we are going to have oil cooler. So oil cooler is gonna remove the heat from the engine. That is the oil removes heat from the engine, then it goes through your scavenging pump into your oil cooler. Now, if your oil cooler is working, in that case, what is gonna happen is your oil cooler is gonna use your air, that is inlet airflow, into the engines, where it is going to be passed through tubes and stuff. As the air touches that whole pipe, that pipe is gonna wear off some amount of heat, and you're gonna again send it back. If you don't cool our oil, in that case, what is going to happen is your engines will get hotter and hotter and hotter, and it is going to not lubricate. That is, your lubricant will fail, because your lubricant only lubricate until certain extent, and after your temperature exceeds whatever value of lubricating it is then gonna fail as a lubricating agent, because your viscosity starts decreasing as more and more you're gonna have a higher and higher values. So for this particular reason, we have to cool our oil. Now that is your reason. That is, oil temperature is going to be influenced the heat generated in the engine. The more power, the more heat you are going to have. The cooling of air, how hot or how cold your air is. That is, let's say if you are flying in Florida in a summer, in that case, the outside air temperature is going to be very, very high, which causes us problems. In colder days, it is going to cool suddenly. So this both the conditions could be accounted for. Then what is the rate of airflow? So if you do a VX climb, you are not going to have that much high amount of airflow, which is going to create us problems. Now, in your whole light aircraft, what we are going to do is we are going to be dependent upon air. That is, this is called as air cooling. In that case, how fast are we flying through the air, plus whatever propeller rotation is going to give energy into the airflow, which is being sent into the engine. That is how much you're going to have your cooling effect. So if you do a VX climb, in that case, due to the high angle of attack, we are not going to have a very effective cooling, which is going to create a little higher engine car heating conditions. Then you have shutter control. So this shutter control will be available in high powered aircrafts and in modern aircrafts only, not in small Cessnas and stuff. Now, what is this shutter control is? Your shutter control is basically going to be like this. So let's say this is your engine oil car radiator. You will have small control valves. You can open this like this, which allows more airflow into it. Or in some cases, again, if I have to draw this, it will be like this, where you can close it. So it won't allow a lot of airflow. Where you can use this is, let's say we are on a very cold day. So this is going to be cold day, and you're going to have closed this, because your oil that passes through the radiators is already colder. Now this is not going to help us, because the oil is going to get even more thicker. Your scavenging pump has to do a lot of work in pushing the oil, and the whole oil will not get heated fast. So if you close this, in that case, it is not going to cool that fast. It is still going to be hot, and your whole engine oil temperature can reach the sufficient level of being inside the green arc. If you are flying on a very hot day, in that case, if let's say it was like this, the whole engine temperature is already higher, we don't cool it enough, and it is going to keep on increasing. To cool your aircraft down, we can open the shutter valve, which is going to send a lot of air into it, which is going to help us in cooling our whole oil coming from the engines. Now your diesel engine. So your diesel engines is going to be of a wet sump system, but it also includes an oil cooler. Why do we have a wet sump system and includes a oil cooler? Is your diesel engines are high temperature engines. They are high compression ratio engines as well as high temperature engines. To overcome the effect of overheating of your engines, we have to include both a wet sump system and a engine car like oil cooler, which is going to help in like dissipating the extra heat that your diesel engine is going to produce than your gasoline car petrol engine. Mhm. Then we'll talk about your lubricating monitoring instrument. That is, yeah, we have to monitor all your how your lubricating works. Is it working? Is it in the green arc or what is happening and all those things. So what are the parameters that we are going to monitor is we'll monitor temperature, we are going to monitor pressure, and we are going to monitor your quantity of your lubricating liquid. So your temperature will be measured at the engine pump inlet. That is wherever you have your engine pressure pump inlet, that is where we are going to measure your temperature. And at the end of your, after your pressure pump ka filter, we are going to measure the pressure of your engine. Now, the typical value of your oil temperature is somewhere close to 85 to 90 degrees on an average. And this is going to be indicated via a sensor, or in case if it's a like manual gauge, like whatever we had in our Cessnas, it will, again, it is an electrical gauge that is going to be converted into mechanical energy and you're going to have your values. Now, if you talk about your pressure sensor, so your pressure is going to be sensed outlet of a engine driven pressure pump. That is at the very bottom of your whole flow chart. We are going to sense your pressure after crossing the pressure filter. Now, this should range between 50 to 100 psi depending upon the size and load of your engine. And your sensors will be either electrical or manual like values. So you either have an electrically activated pressure sensor, which is called as a transducer, or you can have a mechanically operated pressure sensor, which is going to tell us what is the flow by either spinning a bearing or something like that, which is going to tell us how fast your oil is flowing, which will be accounted as pressure. Then you can have a quantity. Quantity can be either a electrically measured one, which is going to display that you have such an sufficient amount of fuel. You can have a flow type oil measurement device that will indicate that we have like how many quarts of oil in our oil tank and all those things. If you don't have something like that, you can use a dipstick. That is, however, we used to check our oil quantity in our Cessna. You can use that to measure your quantity. Or you will have a slide glass. So, side glass is basically in your in your oil car tank. If let's say this is your oil car tank, uh, you're going to have a small window like this which will have markings in it. So this you can see through these markings key where is your oil car level is, and by that you can determine what oil level you have and do you have to pour extra oil in it. Now, your flight deck car requirements is you will always have oil temperature or oil pressure, and it should always be indicated in your cockpit because these are the important parameters of your whole engine car operations. And with that, it is going to give us are we going to have a engine failure or not. Now, if you have the correct oil temperature and oil pressure, that means our aircraft is working properly. If you have any abnormal reading, let it be your oil temperature or be your oil pressure, in that case, you have the possibility of having an engine failure and you have to land immediately. So that is why it is very important for our monitoring systems to work properly in any case to not have engine failures. Then talking about the viscosity of your engine. So your viscosity is basically how resistant it is to the flow. So your engine ka viscosity should not be very high. That is, your oil viscosity should not be very high, where it is gonna struggle to move through your pipelines into the engine, lubricate and come back. At the same time, it should not be very very low also, where it flows just like water, where it is not at all gonna do the job of lubricating, where it fails. So you should have a engine car viscosity which is going to be adapted to all temperatures, because our aircraft flies at different altitudes where we are going to have very extreme temperatures of, let's say, sea level may 35-40 degrees, and all the way up maybe -10 -5 or whatever, until whatever our aircraft can go. So for this particular property, we have to choose a oil which is either of very not very low viscous or not very high viscous, something in between. So that is your viscous. So if you're thin oil, it is going to be low viscosity, which is going to flow freely. A thick oil is going to be high viscosity, which flows slowly. That is, it is not going to flow that high faster. Now your temperature, if we choose some kind of viscous oil in between this one, what is going to happen is if your temperature starts increasing, your oil is going to melt and it is going to get thinner and thinner and thinner as much as your temperature starts increasing. The lower the temperature, it is going to get thicker and thicker. So this should also be accounted for. It should not get thinner as fast as possible. At the same time, it should not get thicker also at the same time. So you have to account for that. Now, your viscosity ka index is the oil's ability to maintain proper viscosity across all operating temperatures. So that is when from the time you start your engine all the way till you land back again, your viscosity should be at the same rate or more or less at the same rate. It will always definitely it will start thinning at certain temperatures, but it will not thin as much as going from very thick engine oil to very thin like water and stuff. It can maybe decrease a slighter amount, but not to a very greater extent that you're definitely going to have some performance issues in your aircraft. So we have to make sure that we have that type of viscous oil. Now, your viscosity oil number is going to be based on your standard. So, first standard is called as Common Aviation Standard, SAE. Now, this is what we'll have in our oil cans and all. It will say SAE and it will say 30, 40, whatever number it is. Now, your SAE stands for your Society of Automotive Engineers. So, these people have designed that they have tested all sorts of oil, fuel, and everything that is correspondent to your automotives. Anything that has an engine is an automotive. So, airplanes also fall under that. Now, we use numbers. That is, we have the second one is called as your Say-Bolt's universal constant. Now, Say-Bolt's constant is going to have numbers. So both of this number means that if it's like lower number, that means it is a thinner oil. That is, it is low viscous. So your SAE number will be half of whatever your Say-Bolt's number is. If your SAE number is 30, your Say-Bolt's number will be 60. If your SAE number is 40, your Say-Bolt number is going to be 80. So to identify, let's say few countries they use SAE numbers, few countries they will use Say-Bolt's number. If you don't know which one to buy or which one to not use, Say-Bolt's is half of your Say-Bolt's is twice your SAE ka number. So just multiply your SAE number by 2, you're gonna get your Say-Bolt's. Since in US we use SAE ka numbers, we'll go by this. Now your oil, the light engine, we are going to use low viscous oil, which is going to help us in operating all temperatures and conditions. Now, if you are using a very high powered engine, then we have to use a thick oil, because since the whole high pressure it is giving or the high power that is giving, there's going to be a lot of heat generated. The higher the heat generated, the faster your oil is going to lose its viscosity, which is going to bring back. So let's say if you use a 60 viscous oil, it will go back to 30 for this particular reason. But if you are using a 30 viscous oil, it can have chances of going less than 30 to 0 also. So this should be bought yeah, thought with care. So not every single engine is going to use the same oil. That is, we will use different types of oil for different properties. Now, your oil selection, that is when you also have a climatic impact. That is, you can in winters and all those things, we have to use a thin oil, because if you are using a thick oil due to the very cold temperatures, your oil will become furthermore thicker. That is going to cause problems with it. So you'll use a low grade oil, which is a little less viscous than whatever we were normally using. If it goes to summer, in that case, you have to use a higher grade oil, because your oil is going to be has to be slightly thicker to account for the temperature changes. So your oil doesn't like go all the way to watery wala state where it is not at all going to lubricate us. Now for these purposes, because we can't simply keep changing oil every single time, remove oil, whole oil, put it back again and all those things, we have something called as a multi-grade oil. So multi-grade oil is, it can work at any viscosity and any temperature. It doesn't have any specific temperatures and specific viscosities also. So SAE 15W50 is going to work across all temperatures. So these are the examples. That is low viscosity at cold starts, and it also provides high viscosity at high operating temperatures. So you don't have to go and find for like 30 in summers and 60 in winters, or the vice versa and whatever. Now, if you use a very high viscosity oil at low temperatures, this can cause you starting issues. So you have to be sure what type of oil are we using, and you have to always refer to your manual to find out what oil is should be used, what say number or Sable's number can be used to for your oil for your engine, so that your engine works without any problem at all. So this is your viscosity grade and numbering. Next is we have types of oil. So we have like mineral based oil, you have straight oil, compound oil. Now, what is the difference between these three things is mineral oil is basically made up of your natural minerals and all those things which your piston engine uses. So this mineral oil will be got is the cheapest one of all things that you have. It has no additives and all those things. Straight oil has no additives. That is, we are not going to add any sort of like deration agents, or we are not going to have use anything that can cause increase or decrease in viscosity and all those things, which is going to go by its viscosity number. So it can be either a SAE number or it can be your Sabolska number. Second one is we have compound oil. That is, we are going to add something to it, like antioxidants, detergents, and oilness agent. So all these things, antioxidant is not going to help your like oil oxidize, which helps us in maintaining the oil car life for a extra period of time. Detergents is used in your oil to not let froth happen, so that it is not going to froth that faster. That is, it's a deaeration agent. And then your oilness agent is, whenever we use oil, it will always be slimy and it slips and all those things. If you use an oilness agent, it does the job of oiling, lubricate, and all those things. At the same time, it is not gonna stick to the surface also. It doesn't become a greasy, well, I think where if you keep your hands, it is gonna get stuck with each other. So this is going to be named as AD. That is, you've added some type of antioxidants or any kind of additives that is there. So AD80 or W80, which is going to help us in identifying what type of additives is added. So your AD stands for your ashless dispersant. That is, it is going to clean your engine car components without by dispersing all the ash that is inside your cylinders. Now we can use straight oils mainly in running in a new engine. In whenever you are buying a new engine or you're fixing a new engine into your aircraft, you have to use straight oil only, because that has like no additives and all those things, which can bring up the life of your oil by lubricating all the parts. You also have semi-synthetic oils that are approved by some of the manufacturers. So semi-synthetic oil is going to be between straight oil to your compound oil. You don't have all the additives that should be there. At the same time, you don't have no additive at all. It is going to be something in between where it helps us the job of lubricating. So these are your types of oil. Then you have your operational considerations, that is your indications. So your monitoring and all those things should be done. Why should we do it is, we can check whether your engine is working properly, or is there any problem with your engines that can come in the future. Your oil indications give us way advanced information about what is going to happen to your uh, like what is going to happen to your whole engine way before itself. Now, if whenever you're starting and you warm up, you have to always make sure that your oil pressure is in the positive and within the specified limits. We should always make sure that our oil temperatures and stuffs are in the green arc. Whenever you start your engines in a cold start, in that case, there is always going to be a high pressure system, because whenever you do a cold start, the oil inside your whole oil system is going to be of a little higher viscosity. So this has your engine has to warm up first, and then only you can move your aircraft, so that we don't damage our aircraft ka pressure pump. Now your temperature and pressure are dependent. That is, you're gonna have, if you have a high oil temperature, that means you have a low pressure inside your oil gas system. If it is a low pressure, it can be of many reasons. That is, you might not have enough oil inside your system and all those things, or you have a hand like oil leak or something, which can give us what is the exact situation that is happening. So if you see a low pressure warning indication, that means you're gonna see a high oil temperature warning indication. So both of them are interdependent. That is, they are both dependent on each other. Now, if you have a abnormal indication, that is, if you have low oil level or system fault, that means you're gonna have a engine failure soon, because you're leaking oil. At as time goes by, your engine temperature starts increasing, which is gonna create higher and higher temperatures. At the end of the day, you're gonna have a engine failure. So you have to land your aircraft as soon as possible. Now you have other like words that we have to remember is scoring. That is, if you have very cold weather, then in that case you're going to have a very thick oil which will not circulate. So this thick oil which is going to be not circulating is going to like create problems for us, because we are going to not going to have effective cooling. So in that case, like our Seneca's and all, we have this cowl flaps. We can close the cowl flaps. By closing it, the whole engine ka temperature is going to heat up your oil, and the job of the oil temperature is going to come up again, and then you can open it after some time. If you forget to open it after some time, your oil temperature will keep on rising and you will have a high engine temperature ka warning again, which is going to give us problems again. So you have to make sure that, remember that you have closed your cowl flaps and you have to open it also. Now, your oil consumption. So it is basically that we always have to have some idea of how much our aircraft is going to consume. If your oil is consuming more, that means there is more wear and tear inside your engine and your engine has to be replaced. So if it's a good, very good aircraft with a very new engine and all those things, in that case, it will consume 1 pint per hour. Otherwise, if it's a very like bad engine, like our aircraft, like 1302 uniform and all, will consume 1 quart of oil if you go on 100 nautical cross country in one single leg. That means the engine car level is, sorry, the engine car health is very, very bad and it needs a engine replacement. Now, during your pre-flight checks, how to check your oil is, whenever if you have a dry sump system, you can check it immediately after shutdown before your gravity drain sump. So many large pistons, they are going to have a check valve where you can use it and you can check how much oil do you have. Because by the time when you have shut down immediately, scavenging pump would have sent some amount of oil back into the pumps, back into the oil tanks. So it indicates us more or less accurate values of what exactly is your oil car level. If you use a wet sump system, in that case, you have to wait like for 15 to 20 minutes after shutdown, because your oil has to drip, all the oil has to drip into your wet sump. And the second reason is the whole whole engine is going to be hot. So if you try to open something that is very, very hot, the pressure inside, if it's not escaped, it can also like blow back into our faces itself. So we have to pay attention that we don't open our engine car oil if it when it's very, very hot. So you have to be sure about it. So I guess we are done. So this is the end of your lubricating chapters.